Hey everyone, welcome back to my channel. Today we're going to be working on problem number 2091, removing minimum and maximum from array. Let me just make sure I have signed in. Cool. So this is a problem I'm working on the first time. I've never worked on this before. Most of the time I only work on problems that I have never worked on in the past. Sometimes if I do retake a problem from the past, it's a problem that I could not successfully submit. So the problem goes, you are given a zero-indexed array of distinct integers nums. There is an element in nums that has the lowest value and an element that has the highest value. We call them the minimum and maximum respectively. Your goal is to remove both of these elements from the array. A deletion is defined as either removing an element from the front of the array or removing an element from the back of the array. Return the minimum number of deletions it would take to remove both the minimum and maximum element from the array. So we have an array of unsorted numbers or integers, 2, 10, 7, 5, 4, 1, 8, 6, and the maximum number is 10 and minimum is 1. So the number of deletions that they made are 5. So it's 1 from here, also 1, 2 from here, and then 3 from here. 1, 2, 3, 4. Yeah, so the minimum element in the array is nums1, which is 1. The maximum element in the array is nums of index 1, which is 10. We can remove both the minimum and maximum by removing 2 elements from the front of the 3, from the front, and 3 elements from the back. This results in 2 plus 3, which is 5 deletions, which is a minimum number. Let's say we did from here to here, then it would be 1, 2, 3, 4, 5, 6, so it would be 1 more. Let's take a look at this one. So this one is minimum is -4, and maximum is 19. The minimum element in the array is nums index 1, and the max element in the array is nums index 2, which is 19. We can remove, okay, so obviously we can just remove these two. And in here, there's only one element in the array, which makes it both the minimum and we can remove it with one deletion. So let's discuss the steps. But before we even get to the steps, let's look at the constraints. So 1 is less than or equal to nums.length, which is less than or equal to 10 to the power of 5. Negative 10 to the power of 5 is less than or equal to nums index I, which is less than or equal to 10 to the power of 5. The integers are all, and nums are all distinct. Okay, so that's a good sign. That aside from this, I don't think there are too many edge cases. Let's take a look at maybe if we had something like, so 2, 10, 1. Let's say if we moved a 0 here, right? The 0 becomes minimum. This should give us 3. So let's say we return 0 as a sample, and we pass in this in our sample test case. But I think that's just similar to this. Let's say we pass in 0 from, so let's cut 0. And then rerun it. And now the expected answer is 3. So it's 1, 2, and then 3. Once we remove this 3, then it is 1, 2, and then 3, 4, 5. Obviously, as according to the example. So there's not really much edge cases to consider. Wait a second. Oh, I did not change it. Sorry. Remove the 10. So now it should be 5. Cool. So this, there aren't too many other edge cases to consider. So the steps for this problem, I'm thinking first we can just use a one-pass loop to find the max and one-pass loop to find the min. That would be O of n plus O of n, because we're just doing single passes each time. Once we found the max, we want to keep hold of the index we found it in. So let's say we found the max to be 10, index is 1, and then we found the min index to be 1, index 0, 1, 2, 3, 4, 5, right? So if we know, for example, so there are two ways of proper deletion. If the max, it's either from the front or from the back, right? So from the front, if we know, let's see what the minimum would be for the front. Is it from the front or from the back? So we would know, for example, to get to index 1, that's only one step. And then to get to here, which is index 5, that's 1, 2, 3, 4, 5, 6. Sorry, to get to index 1, that's 2 steps, and to get to index 5, that's 6. So in total, we would have 6. One thing we can do is, yeah, so we know that this is on index 5 and this is on index 1. So whatever the max is, so this is index 5, and index 1, whatever the max is of the index, we can just subtract that based on the length of the array. So if the array size is 1, 2, 3, 4, 5, 6, 7, 8, so it would be, we would compare what is 8 minus 2 plus 8 minus 3. Or, yeah, so is 8 minus 2, which is uh, 6, and then minus 3, which is 3, is 3 less, or is 8 minus 1, 2, 3, 4, 5, 6? Okay, so basically all we need to do is, first after sorting it, we find out max length of the nums, and then once we do that, then we make max or furthest integer from an array, and then we do length minus furthest. So we could just do like math.min length minus furthest, or the but what if we had 10 here, right? So if we had 10 in here, it would be, so one thing we could do is we could try, all right, what is it from here to here? So length of the numbers, what we also need is index of min and index of max, right? So there are 3 possible ways. One is all the way down to here, right? This and then this. So it would be math.min length minus furthest, or we can just index. So if, for example, the last is less than, so if the last number is less than, okay, so we have the index of the min, we have the index of the max. If the index of the max is closer to, or the index of the min is closer to nums.length, and the index of the, well, first we need to find out how close these are, right? If there's a lot of if there's a lot of deviation between the indexes, so like in this case, it's pretty straightforward because they're both closer to this index. So the minimum number index falls in 1 and the maximum number index falls in here. Then all we need to do is basically from index 0 to 3, and then from here we can know that the length is, yeah, okay. So there's really just two main conditions. If the numbers are very far apart, like you see here, in which one number is very close to the length, and the other number is close to the index, then we would obviously find the min between these, right? So you do math.min, which is length minus furthest, or the length, the count index plus, so it would be min index plus max index. So it would be min index plus max index, which would be here from backwards. Okay, yeah, so in any case, you can always go from length minus furthest. So you can go from here to here, or from here to here, or you can go from here, and then you can just check out those 4 conditions. And then you can just do the min. So you can do from here to here, and then from length to here, and then find the min. But in our case, you can either go from here to here and here to here, or from here to here, or from here to here. So there's 3 conditions. So in each case, you can actually try for every single one. So you can try from here to here, and then here to here, or from here to here, or from here to here. Whichever is min, and we can just calculate the minimum from these 4 outputs. Let me think if there's a better way. Let's say from here to here. Yeah, so if the distance, we can actually calculate the distance. So if the length is here and the min and max are both less than, so the distance between these two is less, then we can actually approximate this. So let's get started. So the first thing is first find min. And for that we pass in nums int min equals nums. Let me create another method for this. If so, int max equals something dot value for int equals 0 I is less than dot length I plus plus if num index I is less than max equals num index I, and then in the end we just return max. So we have the max, let's see, if nums index I, oh sorry, this should be max, int max equals, int min, sorry, so min is the max value if nums index I is less than min, okay, min equals if nums index I is less than min, cool. So we can just copy this and get the max and find max. Max and in here we change min value. Cool. So int max equals find max. Also, it's sort of redundant, but we also need to know the index, right? So for that, we can just do like a pair class plus pair. Int index. And int min or max. Index is dot okay. Once this is done, so int min int index equals 0. So index equals I. Let's also change this. Index equals 0. Index equals I. Return new pair. Where we return the index and max. return new pair, and then we return index, and then we return the min. This not min or max. Okay. Pair, min pair, and then we do pair max pair equals find max, where we, okay. Return new pair index. Okay. So now we have the max pair and the min pair. What we discussed is the int min index equals min pair dot index int min num equals min pair dot min or max, and then int max index equals min pair dot index, and then int max num equals max pair dot am I doing this right? Yeah, pair max pair dot min or max. Okay. So now we have these two. Okay. So what we need to do is, I guess, the bulk of the business logic. Int length equals then we need to do int max int furthest num equals math dot math dot max equals max index or min index. So let's say the furthest num is this, and the int closest num equals max.min min index or max index. So int closest num index, and let's rename this so I don't forget. So now we have the closest num index and farthest num index. And if okay, so int, let's do length minus furthest num index. So which is min? Length minus furthest num index. Okay, and output equals math dot min length minus furthest num index. So this or one second, we need to do this and this. Okay, and both ways equals yeah, So it would be 0 plus closest num index. So it would be closest plus index plus 1 plus so closest num index is this, and then furthest num index is length minus and furthest num come back equals max, sorry, length minus max index. And from here we could just do closest num index, which is 0, 1, plus length, which is, let's say, 8 minus max index. So 0, 1, so this would be 1, 2, this would be 8, 8 minus 0, 1, 2, 3, 4, 5. 8 minus 5, that is correct. 3. Plus 1, so what is minimum? So into both ways is minimum. So is both ways minimum, or is the length minus furthest num sorry, it should have been not max index, furthest number index, because we didn't know that. Closest number index, so it would be closest number index plus 1. So is this the max, math.min is this, and this, or is it length minus furthest num index? So into both ways, or and other output equals math.min. So far we did length minus furthest num index, which is this. No, it would be length minus closest num index, or both ways. And okay, or 0, so it would be furthest num index, which is up to here, or so is it the furthest num index up to here, or the output? So this one and this is covered. This is covered. So length minus closest num index. furthest index plus 1. So this is covered, this is covered, closest index plus 1. And we did say this is covered, and output. So is the output is less or the other output? So let's say we do this and see what we get. Okay, public here. Okay, okay, private this dot index. Okay. Okay, pair min pair, find min, max pair, find max. That's good. Min index is min pair dot index. Okay, and then min num is min pair dot min or max. Max index is min pair dot index. So it should be max pair dot index. Well, that would have been a big bug for us to max num, min num. Okay, so that's good. Int length is nums dot length. So int furthest num index is max num index or min number index, either or. Then closest num index is math dot min, and furthest from the back is length minus furthest num. Closest furthest num index is here, closest num. So furthest number from the back is length minus furthest num index. Okay. Furthest. Okay, so both ways is closest number index, which is this. So in both ways is closest num index plus furthest from the back plus 1. Output is length minus closest num index, or both ways. And other output is furthest num index, which is this right here, plus 1, or the output of this. So in the end, we return the other output and see if this works. Private pair, line 46, there is an error. Oh, silly. And nums. Output is 4. So there's a little bug. Let's see what it is. I have a debugger tool in here built in. So let's debug this real quick. For this, num index is 5. 0, 1, 2, 3, 4, 5. Yes. Closest num index is how? 0 math dot min index. Closest. So min index. Max index is not 0. Why is max index giving us the wrong output? number index um, find max integer dot min value and index equals 0 if nums index I. Oh, oops, I see what the issue was. Okay, so this works. Let's run other test cases. Let's try to submit it. All right, awesome. So this worked. Thanks again, guys, for watching, and hope to see you guys soon.